All right, like I said, this is kind of something that you've already done, except this is graphs of nonlinear inequalities. We have graphed linear inequalities, which means we had straight lines, and we just graphed below or above. And we even did ones where we combined several together, right? We graphed like in a polygon, that kind of thing. But this time it's nonlinear. So nonlinear are the ones with curves in it, like the parabola, the x cubed, right, goes up this way and down this way and all that good stuff. So that's what we're going to do now. We're going to just do a combination of those two things. So this is something that should be pretty familiar to you. Before we do that, though, they're going to ask you this question. Again, this is kind of like a substitution problem. It's stuff that you've done before as well. So really, this should be a pretty easy lesson for you. It says, determine whether these points are solutions for this inequality. So I'm just going to write down the points. Then I'll give you the inequality. And basically, this is just substitution. Just plug and chug. Plug stuff in, see if the left side is greater than or less than or whatever it asks you to the right side. If it is, then yes, it satisfies it. If it isn't, then it's not a solution. All right, so they give you a set of points, 4 of them. And they're going to ask you, are these solutions for this inequality? So here's your inequality you're going to use. And they're doing this for a reason. I know exactly why they're doing this, because we're going to do some graphs in a minute after we do this, and in order to see if a point actually works, if it fits, okay, what do they say? It's a solution for the inequality. You're going to have to plug it in and see if it works. So they just want to do it first so that you get the idea. All right, so what we're going to do is basically 4 problems right here. And you're just going to substitute 3 in for x and a negative 4 in for y, and just see if it's a solution or if it satisfies the inequality. I don't think this book uses that phrasing, but I remember learning that all the time. They always say this satisfies the inequality, which means it makes it work, basically is what it's saying. So I got 3 and negative 4, so let's just replace it. So the y is what? Negative 4. Let's see if, I'm going to put a question mark over here, okay? Let's see if negative 4 is less than or equal to this stuff right here. All right, and what is this stuff right here? Well, I got to stick something in there. What are we going to put in there? 3. So 3 minus 2. So let's just see if it works or not. And we just say yes or no if it works or it doesn't work, okay? So again, we're testing negative 4, and this is a 1. 1 squared is 1 minus 3, which is a what? Negative 2. So is negative 4 less than or equal to negative 2? Yes. So we write yes. All right? And we just do it 3 more times, but we're different numbers. So let's use 4, 7 this time. So I'm going to go 7. Again, I always like to put a little question mark right there because I'm not really sure if it equals or not. Sometimes I'll even, when I see that it works, I'll put a little check mark, then I'll put yes. You don't need the check mark, but that's what I do. All right, and let's put the stuff in here. So now we put the x in, which is a 4, so it's 4 minus 2. Quantity squared minus 3. So let's see if this works. 4 minus 2 is 2. 2 squared is 4. 4 minus 3 is 1. Is 7 less than or equal to 1? Yes or no? Not a hard question. No, it's not. Okay, so we say no. All right, so I put a little slash through there. It's not. 7 is definitely not less than 1. All right, that's all we do. Let's do it again. Put 1, 1. So 1 less than or equal. Let's just do it in our head. Can we do this in our head? 1 minus 2 is negative 1. Negative 1 squared is positive 1. 1 minus 3 is negative 2. Is 1 less than or equal to negative 2? Is it? 1's less than negative 2? Now, positive 1 can never be less than a negative anything, correct? So, nope, doesn't work. So there we go. Let's do last one. So again, y, which is 6, less than or equal to, what's that? Negative 1? So stick a negative 1 in here. So negative 1 minus 2 is what? Negative 3. But what are we going to do with that negative 3? We're going to square it, and we're going to subtract a 3. Negative 3 squared is positive 9. Minus 3 is 6. Is 6 less than or equal to 6? Yes. Okay, it's not less than, but what is the key word? Less than or equal to. Yeah, it is or equal to 6. So we would say what? Yes. And that's how you do that. That's pretty basic, isn't it? Yeah, just plug and chug, no big deal. I told you this was going to be easy. All right, now let's do some graphing. Example 2. And we're going to graph something that looks kind of similar to what we just worked on. It's a little different, but this time it's greater than or equal to, and it is x minus 4 cubed minus 2. All right. Let's let's use a graph. I was just going to stick an x and y axis there, but I think the graph might be a little more useful to us. All right, we're going to graph this. If it helps putting some points in, I mean, you should know the basic shape of this and where it starts and which direction it goes and all that kind of good stuff. If you struggle with these, I would do a little chart right here. Okay, and but you should know at least where you start, right? What is that? Let's do the minus 4 first. What is that minus 4 inside of the cube? What is that going to do to our graph? It's going to make it go to the right 4 places, okay? So this goes to the right 4 places. What is the minus 2 on the very end? What does that make it do? It goes down 2. Whoops. If I could write, it'd be nice. It goes down 2 places, okay? So at least we got a starting point, don't we? That's always good. All right, so I'm going to go 4 places to the right. 1, 2, 3, 4, and I'm going to go down 2 places. All right. So I got a nice spot right there. That's going to be an important point for us when we graph this thing. Now, what is our function? What's our parent function? It's a y equals what? X cubed. What's y equals x cubed? What's the basic shape of that? It's a squiggly. Yeah. Goes like this. I don't know if it has really a name, to tell you the truth. Like, if they both went up, that would be a parabola. If they do this, I don't know if there's a name for it. I don't think I've ever heard anybody say it. But anyway, looks like that, right there. Everybody got that? All right, so we're going to do the same thing here, but we want to be kind of careful about like how far. I'm not just going to do this. Everybody look at this. I'm not just going to say whoop and whoop like this. All right, whoops. Okay, I'm not just going to do that just arbitrarily. Okay, I want to at least have a couple points where I know it's going to go through. So how do I pick those points? What points do I pick over here on my little table? Well, I know it's going to go here, and I know it's going to go up. But like, how steep is it going to go up? Well, let's pick one point to the right of this point right here. How far did we go over? This is at 4, correct? So let's try a what? What's an easy number to pick? Let's pick a 5, right? So let's put it in for this. This is why we did part 1, right? The example 1, because of what we're doing right now. So let's put a 1 in, or I'm sorry, put a 5 in for this. All right, so let's do it. Can we do it in our head? 5 minus 4 is 1. 1 cubed is 1. What's 1 minus 2? It's negative 1. So watch. If I go to 5, where am I going to go? To negative 1. Everybody see that? Now, remember, this goes up like this and it goes down like this. So what if I go to 4? Where do you think it is? Without even using your table, without even putting a number in, if I went over to 3, I should say. If I went over 3, where do you think it's going to be? It's going to be down the same as that went up. Does that mean we have a nice straight line right there? No. Okay. So just to make sure that I know like how far, like, is it going to go like super wide? Is it going to go really steep? All right. I need to know that to get a good idea what the shape is. And really, after that point, I'm kind of done putting in points. I'm good to go. So let's put another number. So I put in 5. We just went to negative 1, didn't we? Let's put in a 6. Let's see what we get. Okay, so put a 6 in for this. 6 minus 4 is 2. 2 cubed is 8. 8 minus 2 is 6. So what does that mean? I'm going to go over to 6 and then go up what? Just put it right down. 1, 2, 3, 4, 5, 6. So it's going to go here. Do you understand where we get those points from? Somebody asked me the other day, how do you know which points to pick? Well, pick the starting point, all right, where it emanates from, everything comes from, and then just pick one to the right of it, pick 2 to the right of it, all right, and just kind of see where it's going. So you see what's happening here. Now, what if I did this? What if I put in a 2 for that? You could just put it into there and figure out where it's going to go, but if this one, I put in a 6, I went up 6, what am I going to do here? If I go over 2, what's it going to do? It's going to go down 6, isn't it? 1, 2, 3, 4, 5, 6. Did I do that right? No. It's going to go from here down 6. No, I was right. So, what was I? Okay, started here. If you went over 2, you went up. Actually, you went up to where? You went up 8, didn't you? Everybody see that? Okay, so if I go over 2, I went up 8. So if I go over 2 this way, how far am I going to go down? I'm going to go 8. 1, 2, 3, 4, 5, 6. It's off the graph a little bit. Probably lies pretty close to that. So there are your points, okay? That's where it's not super, super accurate, but it's pretty close, right? So I'm going to start here and try to get through there like that. And then this goes down like that. Should have hit a little bit better right there. My curve wasn't super great. Let's try it again. There we go. Oops, that was even worse. There we go. That's not too bad. So it goes up like that, and that would be your graph. So if they asked you to graph that, that's what it would be. But the problem is, it's not y equals. What is it? Y is greater than or equal to. So, which way do we shade? Do we shade out here on this side of the graph, or do you shade over here on this side of the graph? Well, that's a good question. So what are we going to do? Plug in 0, 0. That's the easiest. You could plug in anything, okay? Obviously, I wouldn't plug something that's going to be right on it, but I would go either to somewhere to the right that you know it lies to the right, or somewhere to the left. 0, 0 is the easiest one to pick, so that's what I would do. All right? So let's put that in there. This is what we did on example 1. Okay, this is the whole reason why they had you do example 1 for this particular step right here. Okay, stick in a 0, 0 for this. So 0, is it, I'm going to put a question mark, is it greater than this? Let's put a 0. 0 minus 4 is negative 4. Negative 4 cubed. Well, it's going to be negative, right? And to tell you the truth, it doesn't even matter what it is. But what is it? 4 times 4 is, 16 times 4 is 64. Okay? So this would be what? Negative 64. No matter what it was, even if you didn't want to do the math, you know you're going to have a negative minus 2, so this is always going to be what? Negative. Is 0 greater than or equal to anything negative? Yes. 0 is always greater than something negative, all right? So technically it's negative 66, but I don't really even care. I just need to know that 0 will be greater than anything on this left side. I could pick any point over here in this region and put it in, and 0 will always be greater than that number. So 0 is greater than or equal to negative 66. So where are we shading? We're shading on this side. Okay? All this is shaded in. It's kind of counterintuitive, I think, because it kind of looks like it's to the left, but it is above this. I don't know. Sometimes with these nonlinear ones, it's hard to know which way to shade. Sometimes it's kind of obvious, but sometimes if you're not really sure, what do? If 0, 0 is available to us, I stick a 0, 0. So does that work? Yes. So that means everything where the 0, 0 is going to be shaded in. So that means everything to the left of that graph is shaded. Everybody got that? Are you okay with graphing the thing? You should know where it starts, okay? That should be pretty basic, right? We've talked about that a lot lately, haven't we? So that would be go 4 to the right and 2 down, 4 to the right and 2 down. So that point right there would be 4, -2. So that's a point. Like if you did this on a quiz or a test or something, I'm looking to see if you put that point, all right? And I'm also looking how far you stretched it out. If you would have done this, if you would have just said, well, I think it kind of looks like this and it kind of looks like this. Is that really the graph? Is it that graph right there? No, it's not. So how do you know how far to stretch it out, right? How much to compress it, how much to, what was the other word they used? Compress and expand, right? I always say stretch it out or something, but expand. How do you know? Well, just pick a point right next to it, right? Put it right there. So you know, goes through there. Pick another one, and it goes up there. So there's your basic graph this way, and everything's shaded on the left. Okay. Does that make sense? Yeah, let's do another one. Yes. Yeah, right pass. Let's put the quiz right there, Julie. There you go. All right. We got one more graphing, and then we got one that's kind of more algebra related. All right, so let's do this. And this one's got an absolute value, and the next problem after this one that's algebra related, that has absolute value as well. All right, so example 3, and it just says to graph. Thank you. All right, so here it is. Y is greater than 3 minus absolute value of x plus 2. It's not... Class is out of control. All right, so it's not really written the way we want it. What would be a better way to write this to see? Because remember, we want to find that point where it emanates, right? Where it comes out of, I guess you'd call it a vertex. But, well, I wouldn't go -3. Well, because this is not a -3. What is this? It's a +3, right? So what I'm going to do, watch, I'm going to move it over here. Everybody see that? Is that all right? That looks a little better, right? Because usually when the thing's on the outside of the absolute value or the cubed or the squared or something like that, just right there is good. It's usually on the right-hand side. So that's all I did. All right, so now let's talk about this. What are some of these things doing? What is that? What is this minus out in front? What is that doing to my parent graph? Okay, it flips it, right? Instead of going up, it's going to go what? It's going to go down. Okay, what does that +2 tell you to do? Left 2, right? It goes to the left 2 places. And what is the +3 on the outside of the absolute value going to do? It goes up 3. Good. All right. So this flips it. I'll just say flips. Okay. This makes it go to the left. This makes it go up. So just looking at the equation itself, that it's good knowledge, right? So I'm not like starting from scratch, am I? I mean, I start from a place where I know that, okay, I have a general idea what this is going to look like. It's going to be a V, right? Because it's absolute value, so I know it's going to look like that. It's going to go down instead of up, so it's going to go down because that negative. It's going to move to the left 2 places, and it's going to move up 3 places. So I should have a general idea of what that's going to look like. So let's get our graph. Let's make it a little smaller so it fits on the page here. There we go. We'll do it in blue since I wrote all that stuff in blue. All right, so let's do this. Let's find that vertex, okay, that place where it comes from, all right? So I'm going to go to the left 2 and up 3. So where does that put me? -2, 1, 2, 3, right there. All right, everybody good so far? Yeah, that's easy. Would you agree? That is easy. All right. Now, it goes down, so it doesn't go up. Now, is there a number in front of it, like a 2 or a half or a third or a 5/6 or anything? No, it's just a 1. So on an absolute value, it's actually really easy. If I just go over 1, what's it going to do? Since it flipped down, I'm not going to go up 1. What am I going to do? going to go, no. Down 3? No. Just a regular V, right? What is it? You go over 1 and up 1. I didn't draw that very accurately, but you get the idea. Up, over 1, up 1. Okay? So watch. To the right 1 and then what? Down 1. Okay? To the left 1 and down 1. If you're not really sure about that, what can you do? You can do your little table, right? What is to the right 1? That would be at -1, wouldn't it? Put it in here. -1 plus 2 is 1. The absolute value is 1. But this negative makes it a -1 plus 3. Where does that put you? -1 what? 2, right there. It puts you in that spot. You could do the same thing with -3. 1, 2, 3. Put a -3 in for this. -3 plus 2 is -1, but the absolute value of -1 is 1. But then you're taking this, which turns it back into -1. What's -1 plus 3? It's 2. So when I put in a -3, I go up to 2, right? For both of those. Did I say that too fast, or are you getting that? I don't know. It seems like a lot of you are not paying attention to me, but now watch. If you want, you can just kind of just fill in some points, right? Just extend our line just a little bit. That last one wasn't right on there. There we go. All right, and then you just do this, and then just do this. And then there's your graph right there. But it's not your final graph, though, is it? It's an inequality, so it's greater than. So where do you think you would shade? I don't know. Well, I do know. But if I was you, I'd probably be looking at it and saying, yeah, I'm not really sure where to grade. Is it? It is. Absolutely supposed to be a dotted line. Good call. I got lazy on this. Why is this a dotted line? Because it's not or equal to. It's just greater than. So both of these, settle down. You got one right. All right, so these should be dotted. That is absolutely true. Should be dotted. All right, now where are we going to shade? What if you look at it, you're like, I don't really know. I'm not sure if you shade above or below. I don't know. So what do? You pick a point, right? What's an easy point? 0, 0. If 0, 0 is like super, super close to the line and you're not really sure if you graphed it right and if 0 is actually underneath it or above it, right? You can pick another point that's a little more obvious. Maybe this point right here. That would be what? -2, 0. Even 1, 1's kind of close to that line, isn't it? All right. So, or you could pick 0, -1 or 0, -2, right? You can pick any point. I think 0, 0 is good to pick. I think we're good enough. All right, so let's put in a 0, 0. So 0, let's see, question mark. Let's see if it is greater than all this stuff. Negative, what's this going to be? Put a 0 in there. 0 plus 2 is 2. Absolute value 2 is 2. But you got this negative out here, which makes it a what? A -2 plus 3. So I got a 0 greater than 1. Is 0 greater than 1? Nope, it's not. So do we shade where the 0, 0 is? Nope, so where do we shade? Above it. Okay? And there's where our shading should be. And that's it. You okay with that? All right, we got one more thing. Any questions? Did you do this in Algebra 2? Probably. Yeah. Algebra 1? I don't know if it's Algebra 1, but you probably saw this stuff before. All right, let's do another one. This will be the last one. We're not going to graph this. We're just going to do some algebra, and we're going to solve for something. All right? And this, 1, 2, 3. Yep, this is the next example, so it's example 4. And it says to solve. So we don't have to graph it, thank goodness. All right, so what we want to do is find all the values for x that makes this whole entire left side less than 4. All right, so that's what we're going to do. But what's the what's the one thing about this that we really haven't dealt with, I don't think, this year as far as solving? The absolute value, correct? There is a definition for absolute value, but sometimes it's hard to understand. It's also sometimes hard to explain to you. I even watched some videos on it when I was writing all this stuff down to teach this lesson. And some people did a great job explaining it. Some people just confused me even more. But I'm just going to show you how it works. So the absolute value of, like, what I want to do. Okay, let's do this. What if I said the absolute value of x equals 3? What is x equal to? 3? And negative 3, that's right. And x is also equal to what? Negative 3. Everybody see that? Okay. So now, watch this. You might have something like this. X plus 2 in the absolute value equals, we'll just say 3 again, make it easy. Now, everybody look up here. I hope you're watching. Some of you guys checked out a while back, but that's going to be your fault, I guess. So what if we did this? How would I solve this? Now, look what I just did. If I wanted to solve for x, I said x is equal to what? Positive 3 and what? X is equal to negative 3. So what do you think I'm going to do here? I'm going to say x plus 2 is going to equal what? Positive 3. And what else? X plus 2 can also equal negative 3. Now look, I took them out of the absolute value symbols, didn't I? Just like I did here. I just said x. See, I took that x out of the absolute value. I said x could equal 3 and x could equal negative 3. You understand why it could equal negative 3? Because if I stick a negative 3 in for x, what's the absolute value of negative 3? It's 3. So both of those actually work, correct? So let's do it. I'll show you. I'll plug them in, and you'll believe me. I'm getting doubting looks. I'm getting looks like, Mr. Hamrick, I don't see how this is going to happen. All right? But, so watch. So what am I going to do? Let's solve for x. So I subtract 2, so x is equal to what? 1. Let's do the other one, and then we'll plug them back in and see if they both actually do work. So x, let's do this. Subtract 2, so x could also equal what? Negative 5. Like, that's so weird. Why could it be 1 and negative 5? It's so strange. But let's put them back in and see if it works. Let's put in the 1 and see if it works. 1 plus 2 is 3. Absolute value of 3 is 3. Does that work? Yeah, it works. Let's put that negative 5 in there. That's kind of weird. Put a negative 5 in for this. What's negative 5 plus 2? It's negative 3. But what's the absolute value of negative 3? It's 3. So does negative 5 actually work? It does, doesn't it? Everybody see that? So when you have an equation with an absolute value, how do you work it? You actually write two different equations. One, you just write it the way it looks without the absolute value symbols. Everybody hear me? Once you write it down without the absolute value and then you solve for it. But that's not your only solution. You also change the sign of the thing on the right-hand side. Everybody see that? See what I did? It was a 3. I changed it to a negative 3. And it made it work, didn't it? All right, by doing that, it did give me a solution for x. It gave me my second solution. So that does actually work. So let's go back to this. I'm going to erase all this. Don't you erase it from your notes, but I'm going to come back to this. So now, what do you think you're going to do here? Well, first thing I'm going to do is something we didn't talk about earlier, but I want to make it so only an absolute value is on the left-hand side. You hear what I said? So I only want an absolute value on the left-hand side. So what am I going to do to make that happen? Add a 5. Okay, so I got x minus 2 is less than, add a 5, what do we get? 9. That's a super easy, simple step. Agreed? All right, I just want the absolute value by itself. Now what we're going to do is an absolute value, and what we're going to do is we're going to break it down into two inequalities. right? So the first one, oops, we just write it without the absolute value, and nothing changes, right? Except we just got rid of the absolute value. Everybody okay with that? We'll solve for x in a minute, but I want to put an and. What else do we have? Let's get rid of the absolute value, make it x minus 2, but now what do we do? Since it's an absolute value, I didn't write this in my notes. That was stupid. Oh, no. I'm good. So we just keep it like that. And then what do we do to that 9, though? Well, I don't just write it again the same way here, because then I get the same exact answer for both of them. What did we do earlier? We make it negative, right? So I keep all this the same, but what do I do to that 9? I make it negative. Does that make sense? I'm just double checking, doing this in my head. I just want to make sure that I'm doing this right. Yes. Wait a minute. Hold on. X is less than. Oh, you know what I need? You know what I didn't do in my notes, and I should have done it. And that's what I was thinking. Since let me try to say this correctly, if I could talk. Instead of just making this a negative 9, you remember the rule that says if you multiply or divide anything by a negative, what do? Change the sign. Okay? So instead of making it less than, what are we going to do? We're going to make it greater than. Well, it's kind of like that. It's not exactly that, okay? But it's kind of like, you remember, listen, shh. You remember when you multiply negative by a negative, right? Multiply or divide by a negative number, and you got an inequality, you switch the inequality, correct? It's kind of like this, because what do? We stuck a negative right here. So what are we going to have to do to this then? We're going to have to change the sign of the inequality, right? This, we didn't change anything. This, I changed this from a positive to a negative, and what am I going to have to do to my inequality? I'm going to have to change the direction of it. You see that? It's just a rule. All right, so, yep. For some stupid reason, I didn't do that in my notes, and that's what got me kind of mixed up. Because I thought you did do that, and then I looked at my notes, and I didn't. But it'll work now. So now, we just solve for x. So what do you do here? Added 2, added 2. What's x? X is what? Less than 11. And let's do this. Added 2, added 2. What do we get? X is what? Greater than negative 7. Now, we're not going to leave it like that because there's a better way to write it. There's more of a compact way to write this thing. If we graphed it, you're not going to have to graph it, don't worry. But if we did, because this kind of helps mentally see how we're going to write the answer. What does this mean? It means x is greater than negative 7, and at the same time, it also has to be what? Less than 11. So where is it? It's everything between negative 7 and 11. Yes? So I can't keep going this way, because if I go past the 11, then that doesn't work, right? The and means it has to accomplish both of these things. It has to be greater than negative 7, and at the same time, that number has to be what? Less than 11. So it's got to be somewhere between here and here. Yes? How do I write that in this in the correct notation, though? So x is between, right? So watch. I do this. X is between what? Well, we always start from the left. Negative 7 and what? 11. Doesn't this say the same thing as this? It's just more compact. It's just a little bit more streamlined, a little bit easier to read. Okay, so instead of writing this, which would be correct, I mean, that would be okay, but we're going to write it like this. And does it say the same thing? Yeah, look at the right side. X is less than 11. Isn't that what that says? Look at the other one. Now, this time we're reading from right to left, though, aren't we? X is what? Greater than negative 7. Everybody see that? And then it works. So that means any number in between here will satisfy this inequality. Let's pick one. What's What's an easy number between negative 7 and positive 11? 0 would be an easy number. Let's see if it works. Put a 0 in for this. 0 minus 2 is negative 2. Absolute value is 2. 2 minus 5 is negative 3. Is negative 3 less than 4? Yes, it is. Let's pick a number that does not lie in that region. Let's pick a number over here. Over here. Negative 2 does not lie over here. Negative 10? All right. Let's pick negative 10. All right. Let's see if it works or if it doesn't work. Let's watch. Shh. Listen. Let's put negative 10 in for this. Negative 10 minus 2 is negative 12. The absolute value is 12. 12 minus 5 is 7. Is 7 less than 4? It's not. So, nothing over there is going to work. Let's pick a number to the right of 11. Let's see if that works. Give me an easy number to the right of 11. 12. Let's do 12. 12 minus 2 is 10. Absolute value is 10. 10 minus 5 is... 10 minus 5 is 5. I was thinking of the next number. 10 minus 5 is 5. Is 5 less than 4? No. So, do any numbers over here work? No. Only the numbers in here. So, this is how you write your answer. Again, that should have been an Algebra 2 topic. You probably have seen that before. Do you remember doing that thing where you make it plus and minus? Yeah. But you got to remember, when it's an inequality, what are you going to have to do with this when you make the other one minus? You got to change the sign of it. And I got to change that in my notes because I didn't do it. I was probably in a rush. Anyway, that's how you do it. Everybody okay? All right. Okay, so I gave you a lesson plan today. Page 150, 20 to 31. Not odds. 20 is not odd. So it's 20 to 31, and it's section 3.3. We'll call it A, because I'm going to give you a B on Wednesday. Section 3.3A. All right, so that's all the new stuff we're going to learn before Thanksgiving break. The next assignment is just the same kind of problems, just a tad tougher than what you're doing right here. Okay?